Hello, 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 and welcome everybody. Happy Tuesday. It's time for math. Let's get right to it. Whole number times decimal, part 1. Okay, we're going to go in parts with this because even though really it's just multiplication, right? The decimal point can be a little intimidating at times, can feel a little new, but hopefully by going slow through it, we will alleviate some of those anxieties around our dear friend, the decimal point. As usual, something to write on, something to write with, notebook and pencil, or whiteboard and marker. Okay, don't just sit there and do this in your head. It's a lot harder that way. And then our I cans are down here. I can explain how fractions and decimals can show equivalent values, and I can use an area model to multiply a whole number by a whole number plus some tenths. So let's get started. And again, I'm saying don't let the decimal point scare you, right? Because ultimately, our place value system, our base 10 place value system, the places to the right of the decimal point that show fractions of a whole number, right? Fractions of a unit, parts of a unit, they work the same way as our places to the left side of the decimal that show groups of whole units. Okay? It's still a matter of you have 10 of these. You can convert them in a fair trade into one of these. You move to the left, that's essentially taking your value and multiplying it by 10, right? 2 tens is 10 times as much as 2 ones, which is 10 times as much as 2 tenths, which is 10 times as much as 2 hundredths, right? Likewise, when you move to the right, everything is getting divided by 10 or is 1/10 as big. So 2 tenths is 1/10 as much as 2 ones. 2 hundredths is 1/10 as much as 2 tenths. Okay? The decimal point, all it's doing is it's showing us and it's marking where whole units end and parts of a unit begin. Really, that's all it's doing. Okay? So when we are multiplying a number that has some tenths in it by a whole number, it's important to kind of not go, oh, this is a new thing, right? Because if we take something like, we'll start small, 2.2, or 2 and 2 tenths, times 3, right? 2 and 2 tenths times 3, just like we can take, if this was 22 times 3, let's say, right? You could break this up as 20 times 3 plus 2 times 3. Okay? The fact that there's a decimal point here doesn't change how we can approach this mathematical problem, this multiplication problem. We can separate this up into 2 times 3 plus 2 tenths times 3. Okay? Just like we're putting this in expanded form, essentially what we're saying here with this 2 and 2 tenths is that our expanded form of this would look like 2 plus 2 tenths. Okay, that's the expanded form of our whole number plus some tenths. And if you take each piece and you multiply it by your other factor, and then add those partial products together, just like with a whole number, a 2-digit whole number, you're going to end up with an accurate final product. Okay? So you can use an area model for this. I think it looks and works great. You can say, put our expanded form up here, multiply both parts by 3. 2 times 3 equals 6. Now 2 tenths times 3. What do we do with this decimal point situation? Now, remember back, right? We've multiplied 2 tenths by times 3 before. You could do it as a fraction. You could say 2 tenths times 3, and we're going to put this denominator of 1 here to remind us that the size of this unit is 1 whole. And then multiply straight across. You end up with 2 times 3 is 6. 10 times 1 is 10. Tenths times wholes is still tenths. So you end up with 6 tenths. Now, let's write that as a decimal. 0 in the ones place, have your decimal point there, and 6 tenths. Okay, and then we can take 6 plus 6 tenths. Scoot back a little bit so I can do my partial products down here. 6 plus 6 tenths equals, well, 6 and 6 tenths, just like you would a mixed number. Okay, if I wanted to do it in vertical form, same thing. 6 plus 6 tenths, right? Just like we talked about with adding decimals, we want to make sure the decimal point is lined up. Okay, if you end up adding the 6's, now you're no longer adding, it's like adding 60 plus 6 and getting 120. It doesn't work, right? So 6 in the tenths, keep our decimal point lined up, and then 6 in the ones. Okay, so that's kind of the long and short of it. We're going to go with one more practice before we get to our digital whiteboard here. And I want to look at one that's a little bit different. So instead of 2 and 2 tenths times 3, we're going to do 2 and 4 tenths times 3. Okay. And the reason for that is I want us to do a little bit of regrouping here. Okay. Because when we think about 4 tenths, because we know we're going to have to do 2 and 4 tenths, so expanding that out, times 3. 2 times 3, still 6. Now we're doing 4 tenths times 3. Or if we want to think about it as repeated addition, 4 tenths plus 4 tenths plus 4 tenths, right? When we add fractions, denominator stays the same, so we're still in tenths. And then we add our numerators, 4, 8, 12. Okay, 12, how do we write 12 tenths as a decimal? That's our next question. What can we do? Can we make a whole number from this fraction? Yeah, right? We have more than 10 tenths, so we can make a whole number out of it. If we do 12 tenths minus 10 tenths, because 10 tenths, as we know, equals 1, we're left with 2 tenths. So this 12 tenths is in essence 1 and 2 tenths. By converting that improper fraction to a mixed number. And we can write 1 and 2 tenths as a decimal, right? We have 1 whole, put our decimal point there, and 2 tenths. Yeah? Now we can add 6, and I'm going to put 6 and 0 tenths to remind myself that there's a tenths place there. 6 and 0 tenths plus 1 and 2 tenths. Now add the tenths together. How many tenths do you have? Add the ones together. How many ones do you have? For a final answer of 7 and 2 tenths. Okay, this can become particularly useful, this idea of really thinking about 4, and one thing I'm noticing, zoom in on this here. 4 tenths times 3 equals 1 and 2 tenths. Do we see anything familiar in here? I'm almost seeing 4 times 3 equals 12. Are you noticing that? Because I'm noticing that. So 4 times 3 equals 12. So 4/10 times 3 equals 12/10. I wonder how we could use that to our mathematical advantage here. Thinking about, all I have to do is take out the decimal point or move the decimal point and then put it back at the end. Because couldn't I, essentially what I'm doing here, if I take that away, I'm multiplying by 10, right? 12/10 times 10 is 12. And then when I put my decimal point back in, I'm dividing by 10. Hold that thought. We'll come back to that later. For now, let's think about this kind of idea here of using our area model, splitting it up into tenths and whole ones, and then adding those partial products, right? And because we have familiarity with converting these into fractions, don't be afraid to use that, okay? Let's try a couple on the digital whiteboard here. First one here, 9 2/10 times 4. Go ahead and try that on your whiteboard or on your paper at home. 9 2/10 times 4. While you try that, I'm going to get distracted by the crows right outside the window. There's 3 of them. They're hopping around on the roof of the neighbor's house. Okay. So, set up your area model here. 9 2/10. And we're going to multiply both parts times 4. 9 times 4. Any way that works for you. If you have that automatic, great. If you want to think about it like 10 times 4 minus 1 times 4, right? 10 times 4 is 40 minus 4. Think about it that way. If you wanted to do 5 times 4 plus 4 times 4, that would get you there too, right? Lots of different ways to get to 9 times 4 equals 36. And then we have 2/10 times 4. Right? Or 2/10 plus 2/10 plus 2/10 plus 2/10 equals how many tenths? Right? 2 times 4 is 8/10. And then put them together. 36 plus, now, here's what I'm anticipating seeing. See how there's 8/10 here? Make sure you're remembering that always with a whole number, there's that decimal point just to the right of it, okay? Because what might end up happening, what I'm going to hopefully not see, but I'm anticipating I might see, is something that looks like this. Right? And now this is a good time to think about reasonableness. When I say reasonableness, looking at your answer and thinking, is that reasonable? Would it be reasonable for if I had 9 and some change, 9 and a bit, and I multiplied that by 4, that my answer would be 4 4/10? It's not reasonable, right? Saying 8 times 8 is 63 instead of 64, that's reasonable because it's close, right? We just used the wrong math fact. We used 9 times 7 instead of 8 times 8. But often I will see things on exit tickets that are like 20 times 40 equals 80. You would have caught that if you had done just a quick check for reasonableness and gone, that can't be right. And if you think as a mathematician that can't be right, you're probably correct and that isn't right. So keep your decimal point lined up. 36 plus 8/10. Our 8 is all the way over here. We got a lot of placeholder zeros we can put in because we have a 2-digit number plus a tenth. Right? So 8/10 and then 36. So we end up with 36 and 8/10 as our final answer. Okay? Let's try one more, and let's try one more. We're going to have to make a mixed number here. Or we're going to have to make a whole unit. Let's try, not that one, that's from yesterday. Let's go down here. Let's go 7.6 times 8. 7 and 6/10 times 8. Now, before we start, let's think about this logically and let's think about this reasonably. Where is my answer going to be about? Right? 7 and 6/10. What two whole numbers would that fall between? 7 and 6/10. If I were going to put that between two whole numbers on my number line, what two whole numbers would it be in between? 7 and 6/10, right? It's more than 7, but we've only got a fraction of our next whole unit, so it's less than 8, right? So being able to say from the jump that 7.6, or 7 and 6/10, is between 7 and 8, right? 7 is less than 7 and 6/10, and 7 and 6/10 is less than 8. That can give us a reasonable figure for what our answer is going to be. So if our answer turns out something completely different, then we can kind of go back and see where we went astray here. So what's 7 times 8? And what's 8 times 8? Because our answer is going to be somewhere in the middle of that, right? 7 times 8 is 56. 8 times 8 is, I said it earlier, 64. So our answer is going to be in between 56 and 64. It has to be in there somewhere. So I'm going to make a note of that at the top. So answer will be somewhere between, there we go, somewhere between 56 and 64. Okay, so let's keep that in mind as we try it. Area model. 2 partial products. 7 plus 6/10, okay, times 8. Seven times 8 is 56, like we just said. And now 6/10 times 8, right? Thinking about, well, 6/10 times 8 is how many tenths? What's 6 times 8? Right, 6 times 8 would be 48 tenths if we're doing it in fraction form. Right, 6/10 times 8 equals 48 tenths. Or 4 whole units and 8 tenths. Right? I'm going to do that work over here in pink. If we had 48 tenths, how many whole groups of 10 can I make with 48? Right? 10, 20, 30, 40. There's my 4 groups of 10, and then I have 8 tenths left over. 10, 10, 10. Well, starting at 0. So my 4 groups of 10 with 8 left over, or 4 and 8 tenths. Okay, this is a really good skill to practice and get better at. So come to office hour if you want to practice this, of being able to take being able to say 126 tenths, right? What does that look like as a decimal? Being able to do it quickly and go, oh, that's that, right? Taking that 126 and ending it in the tenths place. So now we have 56 plus, let me go back in orange for our main problem here. 56, and I'm going to put 0 tenths so I remember where the tenths place is, plus 4 and 8 tenths. 0 tenths plus 8 tenths is still 8 tenths. Keep your decimal point. And then 56 plus 4, 56, 57, 58, 59, 60. So we end up with a final answer of 60. I'm going to rewrite this. and 8 tenths. And does that number fit between 56 and 64? You bet your bottom dollar it does. Okay, so the trick with multiplying a decimal by a whole number, there's a couple things here, right? Being able to think about it in fraction terms, and also remembering this idea of reasonableness. This will help not just with decimal multiplication, but all multiplication, right? When we did our 2-digit by 2-digit review last week, I did see a couple of bobbles in that way of saying like, oh, 10 times 40 is 4,000, right? Or 10 times 40 is 40. Right? Think about it reasonably. If I had 10 groups of 40, if I had 40 tents at a campground and there were 10 people in each tent, would there be a total of 40 people at the campground? No, right? It's not a reasonable answer. Okay? So remember that as you're working on the exit ticket, keep it reasonable. Okay? If you want some practice, and I would highly, highly recommend coming to office hour today, because we are going to be practicing a lot of I'm going to give you a fraction in tenths and practice writing it as a whole number plus a decimal in the tenths place, because that is going to come in handy the more decimal multiplication we do. All right? Thank you for tuning in, everybody. Have a great rest of the morning for math. Good luck on the exit ticket. I hope to see you in office hour, and if not, I will see you this afternoon for the rest of our day. Cheers.